This is a 3D printed MiG-29.
And in this video you're gonna see how you can 3D print it, assemble it and fly it. It features a full 3-axis thrust vectoring, providing pitch, yaw and roll control. But if you prefer, you can also choose to install a standard non-thrust vectoring nozzle, which has a more scale look, but gives you less aerobatic performances. Most of the parts are printed with lightweight PLA, while the reinforcement parts can be printed with PLA Plus or a stronger material. It features panel lines and a lot of surface details all around the airframe to make it look as close as possible to the real aircraft. It's powered by two 64mm EDFs on 6S. So now let's move on to the assembly process. Start by joining the two rear fuselage sections together using the printed alignment tabs. This makes the assembly process quick and help ensure perfect alignment between the parts. It's very important to start from this section as it's the most critical part of the entire build, since it houses the Elevons system. This way, if any mistakes happen during the assembly, you won't have to reprint the entire fuselage. Use medium CA glue together with activator to speed up the bonding process between the parts. Avoid applying glue in this area, unlike what I did here, and if it happens, simply remove the excess glue using a piece of paper before it cures. Now take the two Elevons halves and glue them together, making sure not to let any glue get inside the carbon tube hole. Now cut the 6mm carbon tube using the cutting jig included in the printable files, which will help you achieve a perfectly straight 90-degree cut. Then use some sandpaper to clean up the edges. Then take the carbon tube and the 3D printed pin and glue it securely inside the carbon tube. Make sure it's firmly bonded in place before moving on. Use a piece of paper to wipe away any excess glue. Now assemble the 3D printed Elevons mount using the carbon tube as a guide to keep everything properly aligned, and make sure not to glue the carbon tube to the 3D printed parts during the assembly process. Then take the control horn, and as you can see, each one has an embossed L or R marking that indicates which side it should be glued onto. Then glue it onto the Elevons in the correct position. Now insert the carbon tube into the Elevons, pushing it all the way in. Carefully apply medium CA glue inside the slot, making sure that no glue goes into any of the moving parts. Now do a dry fit to make sure the parts fit together correctly. Then remove the piece, apply the glue and attach it to the fuselage. At this point, it's simply a matter of gluing together all the remaining fuselage sections, using the alignment tabs to ensure everything lines up properly. Between fuselage 3 and fuselage 4 parts, insert the two 6mm carbon tubes cut to the correct length. Gluing them in place is not strictly necessary, but you can do that for additional strength. Now move on to the wing assembly. Just like before, use the alignment tabs to ensure all the parts line up correctly, and glue all the parts together using CA glue. Then take the 6mm carbon tube and cut it to the proper length and insert it into the wing. Then take the tough parts and glue them in place as shown here in the video. Now you can glue the two canopy sections together and then assemble the 3D printed canopy latch. When gluing it onto the canopy, make sure not to get any glue inside the spring section, otherwise it could prevent the mechanism from moving freely. Now assemble the thrust vectoring system. Remove the integrated supports using a pair of pliers, then snap the parts together as shown in the video, making sure everything moves correctly. At first, the movement may feel a bit stiff, but after moving it a few times, it will become much smoother. Then you can glue the control horn, making sure it's straight at 90 degrees. Now you can glue the thrust vectoring units to the fuselage using the guides to align them correctly. I personally use hot glue because it's easier to remove if needed, but you can also use CA glue if you prefer. If you want, you can also install this longer 3D printed control horn, just like I did, to achieve more throw on the rudder axis, if the original control horn is not sufficient. Use a ball link to connect the servo to the thrust vectoring control horns. Now take the longest servo arm included with your servos and install it onto the servo. Then install the linkage stopper and route the servo wire along with the extension cable through the slot inside the fuselage. Then glue the servos to the fuselage. I prefer using hot glue because if needed, the servos are much easier to remove later using isopropyl alcohol. You can now install the servo cover depending on whether or not you decided to install the thrust vectoring system, making sure to choose the correct one. Finally, connect the servos to the thrust vectoring control horn using ball links. Now take the two ESCs. You will need to extend the wires going to the EDFs to the length specified in the manual. I personally soldered the extensions myself, but you can also use pre-made extensions cables if you prefer. Now connect the EDF and make sure it spins the correct direction. Now glue the EDF units into the fuselage using some hot glue. magnets into the EDF hatches and into the fuselage, making sure they are oriented correctly so they lock together properly instead of pushing away from each other. Now install the Elevons servos. Route the servo wire and its extension through the channel inside the fuselage. Then glue the servos in place using hot glue, like you did for the thrust vectoring servos. You can now glue the wing mounts into the fuselage. These are the parts where the bolts securing the wing into the fuselage will be installed. Make sure not to get any glue inside the hole where the carbon tube passes through. You can choose to print the skids in lightweight TPU, or if you don't have any available, you can also use PLA Plus or PTG. Depending on the material you choose, make sure to print the correct version included in the files. Now glue the hand launch grip to make launching easier and provide a better grip during hand launches. You will find alignment slots under the fuselage to glue it in the correct position. The build is finally complete. Make sure everything is connected correctly and perform the final pre-flight checks before takeoff, including checking the center of gravity. Place your fingers on the reference dots underneath the wings and verify that the aircraft balances correctly.